All right, welcome to Skills 4.5. Excuse me. We're trying to make sequences and convert them to arithmetic function notation, rather. All right, let's get to it. Looking at the first example, one of the ideas here that we discovered was that the first term is 16, okay? So we'll say the first term is 16. So if you want to think of it like in a number line, here's 16. And the second term, okay, that's the second term, the common difference is 5. So it's going to be 16 plus 5. That gives you 21. But we're not really interested in the second term. We actually want the term before the first term, which would be a 0. So this one we added 5 to the 16. So if you want to go backwards, you have to subtract 5, okay, from the 16, and that'll give us 11. Okay, so that is actually a sub 0 is actually your y-intercept, and you notice how they got the same thing right here. And our slope is 5, so they also got right there. So the function notation would be that. F of n or f of x or whatever, okay, they have f of n is 5n plus 11. So the idea here is to get your common difference and subtract it from the first a sub 1. Alright, so in order to graph this, you start at 11. If you were to graph this function, you start at 11 and then go up 5 over 1, such as that. Alright, so let's look at number 2. And this is a finite sequence that starts at 1 and ends at 0, so that wouldn't actually be included there. Okay, here we go. Number 2. Alright, number 2. Alright, look at number 2. I'm going to circle the first term. So that's a sub 1 is 50, negative 50. And our difference is 15. So that's the D. The difference is 15, so increasing by 15. So in order to get a sub 0, the term before the first one, you want to do the opposite of D, so it would be minus D. So what I figured out was this. Let's see, where's my erasing tool? No, it disappears sometimes. Okay, so 15, so I'm going to put minus 15, because in order for it to go this way, it's going to be plus 15, but the opposite way would be minus 15. So notice here these are both negatives. When you're adding negatives, you're just saying here's 50 negatives, and here's 15 more negatives, so that's 65 negatives. So that is your a sub 0, or it's also your y-intercept, or your b. Okay. And we already know this is your slope, so your function could be f of n is 15, because that's your slope, n, I almost put x, and then minus 65, which is your b. And here is that function. notation of that. It asks you to graph as well. Okay, so there's no scale here, but it starts at -65. So maybe these are by tens, and it's going up 15. So maybe we can make these, make the x-axis here. My reasoning is that we don't have to go all the way down to -100. Here's your x-axis, and then the y would be here. So it just kind of shifted the x higher. Technically, it would be your n, you know. So your first term would be -50. I'm going to use red. So I'm going to say -10 here, -20. Let me zoom in a little better. I can write better. -30, -40, -50, -60, -70. And then this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the first dot was, the first point was -50 was the first number. So that would be here. And then from there, it's going to go up 15. See, it's up 15. So up 15. Now sometimes it's kind of hard to tell. This chance will be halfway up there. Well, that's in the middle. I think you would agree with that. But you know, you could have said, well, it's up 15 every 1, but it's also up 30 every 2. So you could actually skip. You can go. And you can go up 15 over 1, or you could go up 30 over 2, and you land right there. And then again, 15, 1, and then keep that going. And then we're going to be out of room. You get the idea. Okay. Now, the directions are to graph the function of all integers and such that. So you wouldn't want to connect the dots because integers are whole numbers. Okay. So an integer is a whole number. So you wouldn't want to have an arrow like this. It'd just be the discrete. Okay. All right. So go ahead and try out number 3 and 4. 5 is geometric. All right, for number 7, this is geometric. And it's the same idea here. So this one might be even simpler. Whoops. Let me erase this. So I'm going to circle the first term. Okay, so the first term is 5, and then the next term we're going to be multiplying it by 2. So the next term is times 2, it would be 10. So this is the first term, and here is the second term. The goal is to get the term before the first, call it the 0 term. So if it's multiplying this way, Therefore, it's going to be dividing by 2 this way. So that first, the 0 term will actually be 5 divided by 2. So it'd be 2.5. Okay? So 5 divided by 2. This is the term that we're looking for. All right, and next you want your ratio. In ratio, I'm going to put a square, a little box around it. That's my ratio. So my function will be written as such. F of n is the 0 term, which is half of 5, and then n, excuse me, not n, 5/2 times the ratio, which is 2, n to the nth power. Notice that, here, let me write it again, make it really clear. F of n, which means the function with the input as n. Notice that you cannot cross-cancel these two things because of the exponent. Okay, so that is not acceptable. You cannot cross-cancel these two number 2's because of this the n as the exponent. So that would be not okay. So keep it that way. And how would you graph this? Well, the first term was 5. Now, they put these in 300 increments. Okay? See, they're going up by 300. The reason they did that because they knew that some of these numbers are going to go up really fast. It does make the graphing a bit confusing, maybe. Like, where do you know 5 is? The first term is 5, was really close to 0. That was that right there. The next one is 5 times 2 would be 10. The next one is 10 times 2 would be 20. 20 times 2, 40. 60, 120, 320, 640, 600 times 2, 1200 something, and then doubling that would be 24 something. Okay, see, so this is discrete. We're not connecting the lines, but just for fun, you can see how it could be. You can see the actual pattern. Okay. If you were to connect the dots, that is exponential. All right, for the geometric, we're going to be doing that the next day, but that would be how you would do number 7. All right, just to get you started off on this one. Remember, this is the first term, and we're actually just going to divide that by 3 to get the one before that. Because this way it's multiplying, and this other way it would be dividing. I put an X for multiplying. So my function would be g of n is, this would be -1, because this turns into -1, times 3 to the nth, which you could simplify as g to the n is -3n. Keep in mind that the negative, if you do them separately here, this will always make this number opposite of what it is, the whole thing. So if it's positive, it turns into negative. If it's negative, it turns into positive. So you want to do it, when you do your calculations, do like this. Figure out what 3 to the nth is, and then make it opposite. Okay. So you could also make a t-chart. It's another strategy to use. So your first term was -3, and then the ratio was 3. That means we're multiplying by 3, so that's easy. So multiply it by 3, that would be -9. Is that right? And then multiplying that by 3. And then so on and so far and so forth. So it looks like they're all going to stay negative. I might have made a small mistake on this idea. So whatever comes out will be negative. So then the next one will be 27 times 3. And then the next one, so this will be the second sequence. This is the third, fourth. The fifth one is this number times 3, and so on and so forth. Okay, post your comments of your understanding of how to get the term before the first term. So how to get the 0 term, and that's your y-intercept. Post your comments of how to do that. And once you have that 0 term, how do you find the slope, and how do you put your function together? Those are the comments I would like you to post. Thank you.